to make mobile apps that make a difference in people's lives? In the next 5 minutes, we'll show you a game-changing tablet app for hospital use. But we're really talking about a whole new class of applications that use inexpensive Android tablets running your control panel apps that become part of the products that you sell. We'll show you how we made our app and how you can make something like this too. By the way, this video is the first episode of our new series that we call, Is This a Cool App or What? Hi, I'm Dr. Bob Miller from Trace Systems Inc. We make software that controls hardware for machines, sensors, smart power supplies. We've been making Windows software to control hardware long before the Internet of Things was cool. The product from our client Interface Technologies of Aptos, California is an intelligent upgrade for existing X-ray systems that used to use film only, so that they now use digital radiography sensors. Some of the old system's features to prevent multiple exposures on film, for example, are actually bad when digital sensors are used. IT's product is an intelligent add-on that causes all of the pieces of the upgraded system to now work together smoothly, to be fully plug and play. Here's an important requirement of a system like that. When a patient gets an X-ray, the system must, by law, be set up to only irradiate the smallest area of the body necessary to provide the required medical information. Our client wanted to make a wireless touchscreen control panel that runs on a low-cost, stock 7-inch Android tablet. Delphi's multi-platform app development capability let us use our Delphi skills to make and debug this easy. We developed a system with the tablet talking to a 32-bit PIC microcontroller from Microchip Technology, communicating wirelessly through a Microchip Wi-Fi module. The PIC board is running a TCP stack application that contains a custom web server for diagnostics made with our TCP Maker software and a custom TCP server for the main data flow. The Android app is a TCP Client. It automatically requests updates from the PIC32 server 10 times every second. The Wi-Fi module on the PIC32 board is set up as a Wi-Fi direct access point that only the tablet can connect to. That way, we have private communications between the client app on the tablet and the PIC32 server. As far as the user interface is concerned, the X-ray technologist sees a context-sensitive control panel whose controls and images change to match the setup choices made for the patient. Before the patient arrives, the technologist sets up the X-ray system for the doctor's requested procedure. The tech chooses, for example, a chest stand if the patient should stand, or a flat table if the patient must lie down. As the tech makes the setting, the PIC32 microcontroller also receives that information and sends it to the tablet, which displays a matching image. The cassette, or electronic image receiver, is loaded into the chest stand or table. The size and orientation of the receiver cassette are critical. All that information is received from the X-ray system by the PIC32 server and is transmitted to the client app in the tablet. The Collimator control console client program that's running on the tablet uses all that information it has received to decide, for example, which set of buttons it should display. Each button set is a radio group that lets the tech choose the size and orientation of the X-ray beam. The tech presses one of the buttons in the group to choose the appropriate beam size. At this time, the X-ray source is shining a visible alignment light beam pattern to show where the X-ray beam will be when the actual exposure occurs. Once the system is set up, the patient is brought in and positioned in the visible light field. The tech then goes to the control room, which is protected from X-ray exposure, and presses a button to turn on the X-ray beam and capture the image. The digital system then processes the data from the digital cassette and produces an image. The Android tablet app is a Delphi XE7 multi-platform project using the FireMonkey cross-platform framework for the screen controls, and an Indie TCP Client object. We compiled the project for both Windows Desktop and Android 7-inch tablet platforms. This was great. Though we were not selling a Windows version, we were able to debug the same code on a Windows PC as the code we were developing for the Android. The source code for both is just straightforward Delphi code. The same source code was compiled to make both the Windows binary and the Android binary. That was huge. One more reason why Delphi is the most productive programming environment on the planet. The screen layout consists of a single main form containing nested page controls. The largest page control contains a main page, which is all that the tech ever sees, and a separate diagnostic page that lets the installer guy check the data traffic. Smaller page controls are used to display the X-ray setup type, for example chest stand versus table, and the different sets of buttons for selecting the beam size. Each button in a group also contains a bitmap image of a digital cassette sensor as if it was illuminated by a different size of alignment light field. When a beam size button is pressed, the color of the underlying FireMonkey button changes to a lighter color, which gives the visual impression of a lighted halo around the selected button. Deployment is simpler than you might think. There's no need to use the Google Play Store at all. You are delivering a tablet with your app pre-installed on it. Here's what you do. Right in Delphi, you can sign your Android app yourself. No need to pay for a signing certificate. Compile to a signed APK package file. Then, in each tablet you ship, you temporarily put it into developer mode, install and test the app, and install a Play Store app that causes the tablet to immediately run your app when the tablet powers up, and which will not allow any unauthorized apps to run. Now you are ready to ship your tablet with the other hardware that comprises your product. So, is this a cool app or what? We think it is, but hey, what makes a program cool anyway? Well, here are some objective criteria about what we think makes a cool app. Let's see how we did. Does something useful and important? Check. This is a medical application. It saves lives. What could be more important than that? 2. Teaches a new way to do things that makes the product cost less and work better. Check. Without this tablet approach, we would have had to either use a PC, expensive to provide, or not practical to share the existing PCs in the control room. Or we would have had to build a microcontroller-based touchscreen user interface. There is no way you can cobble together enough parts to make a microcontroller-based touchscreen this good and this ready to go for the $50 you will spend on a cheap 7-inch tablet these days. PIC microcontroller devices are great for working with low-level hardware, but even the largest micros cannot run a full operating system. But a $50 Android tablet has a really good touchscreen, a real operating system, multi-threading, a graphics processor, gigabytes of storage, sound, a web browser, and the ability to display help for your app as text and pictures, or even as video. So, what do you think? Is this a cool app or what? Let us know what you think in the comments below. Or you can click on this link to go to the blog post on our website where you can download an illustrated transcript of this video. And be sure to visit the Interface Technologies website to get the full story on their really cool product.